Hello and welcome to the third webinar in a series of 5 for Elemental, looking at a range of issues and opportunities impacting and benefiting air quality, heating, cooling, health and well-being in the built environment. My name is Jim McClellan, founder and editor of SUSMeme, home to the magazine and the top 500 rankings. Today's session is specifically on air tightness and ventilation. So, focused on design and engineering solutions, product specification to marry thermal performance with good IAQ in different building types, both new build and retrofit, public, retail, commercial, residential. They'll also be debating the relative merits of mechanical ventilation versus passive design. So the whole webinar series is being hosted and produced by Elemental, www.elementalexpo.com, the online community for professionals focused on innovation in heat, water, air and energy, vital elements within the built environment now and in the future. You'll find the full diary of events on the website, including the next 2 webinars in the series on well-being coming up next month in December, plus health in January. You can also view the first webinars on demand discussing going back to work in buildings post-COVID, and the second coming shortly, which is indoor climate emergency. Some great speakers in every session, including the 4 joining me here on screen today, namely Alan Budden, Director Eco Design Consultants, Ian Mawditt, Director and Building Performance Researcher at 4 Walls, Dushyant Karnik, Building Physics Engineer at Enhabit, and Lee Nurse, Business Development Director at Evolution. And this session is sponsored by Vent-Axia, pioneering UK ventilation manufacturer, first established back in 1936, well known of course throughout the industry, now part of the Evolution Group, a leading international supplier of ventilation products delivering healthy air sustainably. So by way of a very brief intro from me, just a little context. In our first session on getting back to work post-pandemic, without obviously understating the terrible disruption and loss, we looked at some of the positive unintended consequences of COVID-19, such as our renewed interest in indoor air quality and ventilation, particularly from the healthy environments perspective. In our second webinar, our focus was global warming, counting the carbon cost of rising demand for heating and cooling, in a debate entitled The Indoor Climate Emergency. Today, if you like, we're very much bringing together those twin themes of air quality and climate breakdown in a practical, increasingly technical discussion of the challenges and opportunities, problems and potential solutions when it comes to air tightness and ventilation. So, from the properties to the people in them, let's zoom in on the issues and bring in our panel. So, as we start to consider how we marry thermal performance, energy efficiency and good IAQ, I'd like to start by asking each of our panelists to introduce themselves and give us their take on the state of play and priorities at present. So briefly, who are you? Where do you fit into the puzzle? What would you highlight as key issues for air tightness and ventilation? So first, from the perspective of eco-design, Alan.
Hi, I'm Alan Budden. I'm an architect and a passive house designer. Set up a small practice, eco-design consultants, just over 10 years ago, specialising in trying to bring the environmental stuff and the architecture together into one place. I think that air tightness and ventilation is really vital. A lot of people think the first thing to go to is insulation, but actually air tightness and ventilation is becoming more and more important, particularly as climate changes and moisture in the air is increasing through the changes in the weather. Then dealing with that moisture is really important in terms of building physics and making sure that the fabric works in terms of moisture not causing rot and damage and all those sort of nasty things. But also it's as important to make sure it's a healthy environment, particularly as we buy more and more gadgets and things. They've got more and more VOCs, sorry, get my teeth in, giving out gases. It's really important that we try and get the ventilation to work properly. And what's so-called natural ventilation isn't really that natural. It's usually a case of having some trickle vents. I mean, it'd be good to do a poll to see how many people listening today actually close or open their trickle vents. I'm sure most of them don't, and that's what most surveys say. So some form of ventilation is really important, and it can really reduce the energy losses by a huge amount. So by the time you get down to passive house levels, if you had standard building regs backstop air tightness, you're increasing your heat loads by way over double. It's a really significant area and really important again for air quality and making sure that the air is changed in the right amount and ventilation and moisture is dealt with. It's really, really important stuff. I think maybe more important than insulation, or at least on the par. I think often, I think, particularly with some of the refurbs, it's suggested now that ventilation is maybe the first thing you start to look at. If there's a house with mold and other things, then probably sorting that bit out first can help reduce some of the losses and reduce fuel bills, but also help in the health. So that's probably my quick analysis.
Excellent, thank you. And yeah, ventilation definitely rising up the agenda, and as you suggest, sustainability in the built environment is very much about joining up the dots between some of the various issues and the various interests. So Ian, as a specialist in moisture and building regs, what's your take, please?
So hi everybody. Yeah, I'm a building performance researcher by profession. In my work, I carry out studies and investigations in new builds during construction and also post-occupation, and also in existing buildings, looking at environmental conditions and sustainability issues, all in the context of indoor air quality being balanced with the need to make buildings more thermally efficient. I guess I fit into this puzzle in a way that with a lot of the field studies and other experiential knowledge I have, I feed a lot of that into building performance standards, and I'm currently engaged both by the governments of England and Wales separately, because Wales is now devolved, of course, for building standards. And I provide technical advice and help them with drafting the revisions, both for Part L, conservation of fuel and power, and for Part F, which is the ventilation standard in the building regulations. Key issues, really, I mean, it's what it says in the title, air tightness and ventilation. It's not air tightness or ventilation. The two are intertwined, they're inseparable. One deals with reducing air movement, whereas the other one deals with ensuring you got the correct air movement inside a building. And these are essential components, really, in any building. You know, it's a three-legged stool situation. You've got to have the correct thermal and vapor properties in a building. You've got to have the correct ventilation in a building. You've got to have the correct heat input in the building. Remove one of those legs and the stool falls over. And now we're making buildings more airtight. That's being driven through regulation. It's being driven even to a degree through consumers now, with climate emergency being triggered in both England and Wales. We're not going to go backwards. Buildings are going to get more airtight. And so therefore, ventilation is becoming even more critical. Its problem currently, which we'll explore shortly, is that it's often, I'd like to say, at least second fiddle to other technologies that go into buildings, but it's probably not even fourth or fifth fiddle. I'd like it to be raised up, because, you know, the health of our planet is important. It's important that we reduce the impact that we have on the planet and reduce carbon emissions, but that can't be at the cost of the health of the people that inhabit the planet. So that's my opening.
Thank you. Yeah, and I think it'll be interesting. We've seen very much how science and data become much more central in the climate discussion, much more central, obviously, in the COVID discussion, and it'll be interesting to see to what degree they get foregrounded as well in terms of building performance and how we expect our indoor environments to actually function and how we measure success in those terms. So I think it'll be an interesting time for the industry, especially in services and ventilation. And Dushyant, as a building physics engineer, what's your perspective on things, please?
Yes, hello everyone. I'm a building physics engineer at Enhabit. We are a low energy and passive house design consultancy based in London. So mostly our work is based on retrofits and new build residential properties. And we also do a lot of mechanical services design and ventilation system design, which is what I'll be talking about today. So in terms of the key issues for air tightness, I think that we haven't realized the importance of air tightness because historically we have been used to living in leaky buildings. And even in terms of the current building regulations for air tightness, it is quite low. And the key thing is that we need to understand the benefits of air tightness and what it can do to make our homes energy efficient, what it can do to protect our building fabric, and how it can increase the level of comfort for the occupants. I think from my point of view, all homes should be airtight, as not only it saves heat, but at the same time, it's protecting your building fabric from moisture, which is really important, as you really don't want moisture to enter your building structure. With improved level of airtightness, ventilation becomes quite crucial because you're stopping the air entering your property via infiltration. So I personally feel in terms of continuous ventilation systems, MVHR is sort of a way forward, because MVHR really helps in reducing VOCs. It improves your indoor air quality. It even deals with the moisture issues, which we usually face in retrofit projects. And also the other important benefit is that it maintains a humidity between 40 to 70%, which has quite a lot of health benefits. However, when it comes to a continuous ventilation system, the most important bit is design and installation, which I think we are lacking in the industry in terms of trained designers and installers. So I feel it's quite important that you have the right design team and installers on site. Otherwise, the system that you have installed won't perform properly, and it can lead to several moisture issues and health-related issues for the occupants.
Excellent, thank you. And I think we'll be coming back to how people get what they ask for in terms of what was specified and how it performs. And it'll be interesting, as you imply, the potential trade-offs between ventilation and air tightness. If ventilation is less of a niche topic coming out the shadows and mainstreaming more, to what degree will the sister subject of air tightness be coming in with it? So it'll be interesting to see how the sort of more mainstream debate tries to grapple with those issues. So fourth of four, Lee, on behalf of our sponsors at Vent-Axia, what are you seeing as key issues, and where are you coming from on this kind of debate?
Okay, I suppose first of all, to introduce myself, I'm Lee Nurse. I work for a pollution group that we own in Vent-Axia. Obviously, where we fit in the puzzle here is such as we're manufacturers of solutions into applications in buildings for the point of view of ventilation. I suppose to touch on and reiterate a point that others have mentioned, obviously from our point of view, the primary impact that air tightness can have on ventilation, particularly if it reduces the amount of advantageous ventilation as described earlier in comparison to older buildings, is that first of all, we want to see that adequate ventilation levels are provided and regulated for. That's the key thing. Ventilation's there for health. That's the primary factor that really must be considered. Appropriate ventilation rates really are critical, particularly as we make buildings more airtight and better insulated. At the same time, I think that the tools that designers have to use to calculate energy efficiency, such as SAP, etc., we must ensure that as they develop and buildings get more airtight, how ventilation and the energy penalty or reward of ventilation systems is treated within those tools continues to develop, to make sure that we capture the things that you need to ensure that decent design decisions are taken in relation to delivering the aim of everybody involved in the process, which is to provide adequate ventilation for health. Air is important. It will continue to be important. In fact, as buildings get very insulated and very airtight, it becomes even more important, particularly as heating loads drop. It becomes a critical element, and it's something we must absolutely all stay focused on.
Excellent, thank you. And so as our four panelists giving you a nice idea of where they're coming from, and already we have a good number of topics and issues in play. And so as we begin to zoom in on the specifics, I'd like to explore some of the issues arising in different building types, be that public, retail, industrial, and commercial to domestic, high-rise dwellings, individual properties, as well as the complexities of refurb and retrofit. So tackling some of that, Ian, why is air tightness and ventilation a health issue?
Good question. And first I should qualify that I'm not a health professional. I'm a ventilation engineer and building researcher and so on, as I said before. But that aside, and also I don't want to go off on tangents about COVID safety in buildings. There's a separate session already being held on that. No doubt there'll be some questions later. But we know there's a significant link between pollutants in buildings, whether it's moisture being a dominant pollutant in homes. We know there's chemical compounds such as formaldehyde, which are carcinogens. We have other organic compounds, many of them in the indoor environment, that cause a range of health issues, be it from respiratory conditions through to carcinogens. So we need to manage them. The problem we have in some ways at the moment is the proof of causality in a health context. It's not sufficiently strong, and that's primarily because of the kind of complex interactions between the agents of illness, if we can call it that, the different types of health that we have as we go through our age. Younger very vulnerable, elderly are very vulnerable, and gender differences as well bring some complexity into the causality. And then also it's about what the building then provides to support our safety and our health within the buildings. So there needs to be more development in providing robust methodologies to understand these issues and how these covariables work together, so we can come up with more robust and suitable solutions. But dealing with airtightness first in this context, I mean, airtightness in some ways, we've sort of talked about it already, but it can be both good and bad. It's bad as in you're reducing potential adventitious infiltration, as it's called, or adventitious ventilation. The downside with that, of course, is it's not controllable. The good thing about ventilation, airtightness, is that the more airtight the building, the better you're able to control the ventilation. So assuming you have the right level of ventilation, you know, the sort of diagrams that architects come up with nice flowing arrows on their plans showing how the air moves from one side of the building to the other. If you've got any leakage in the building, forget it. You know, those arrows aren't going to make any sense at all in practice. The tighter you make the building and the more you can control those airflows through the inlets and outlets in the building, the more likely you're going to be able to follow those airflows. So we know what we're doing when we put purpose provided ventilation into an airtight building. So ventilation is important in a health context as well, because if we're making the building more airtight, we have background levels of chemical pollutants, we have background levels of moisture that need to be ventilated away, they need to be diluted. And we have ventilation rates in the building regulations that dictate what that should be for dealing with those, the sort of off-gassing, if you like, of VOCs and background rates. We have intermittent release chemicals when you go squirting around with Mr. Sheen, probably should say for balance, and other cleaning products, that, you know, you will be introducing pollutants in the short term. From a moisture point of view, you've got bathing activities, cooking activities. So there, in those situations, we may need a higher rate of ventilation. So it's important that we deal with those dilutions through correct purpose provided ventilation. As we move to more and more airtight buildings, particularly as we go to passive house, and you know, and I'm not going to kick passive house at all. I think it's the gold standard in some degrees. The problem, however, is once we get to super airtight levels, is ventilation is no longer optional. I mean, it's not really optional above that level, but it's actually more like a life critical safety system at that level of ventilation, and that needs to be communicated effectively to the building owners, to the people who occupy, homeowners, if it's in a domestic context. They need to understand that you cannot switch these things off. They need to understand that if there's a fault with them, that they need to attend to them as quickly as they would attend to the light bulb blowing in their living room and they can't see anymore. You know, they would soon deal with that and replace the bulb immediately. We need to think about ventilation in a similar way. So yeah, I mean, that's really where I would leave it for now. The only other thing I would say in concluding on this point is the ventilation systems, the air tightness of the envelope, they're all parts of the puzzle. It's the geometry of the building, it's the thermal performance of the building, it's the filtration of the pollutants coming from the outside, the climate of the building, the exposure of the building. All of these things form part of the indoor air quality environment. And we can't just look at air tightness and ventilation and not look at the others. We've got to have a holistic approach to this.
Excellent, thank you. Some very good points, and we'll segue nicely into some of the other speakers as well. And the only thing I'd add on that health issue is our next webinar is on well-being. And often you talked about causality. Health is always talked about in terms of risk and liability. Well-being is talked about more in terms of opportunity and benefits. Now, they're not separate issues, they're on the same scale. You know, these things are on the same sliding scale, if you like. And it'll be interesting, I think, increasingly how we look more at investing in good quality indoor environments, not just to fix problems associated with illness, but to actually deliver benefits associated with well-being and particularly healthy lifestyles and performance in different work and learning environments, for example. But so, in terms of perhaps picking up some of Ian's points about joining up the different dots within the picture as a whole, Dushyant, if I could come to you about how can low energy design be optimized for retrofit in this scenario, not just new build? When we're not dealing with a blank piece of paper, when we're dealing with retrofit, how do we deliver some of that low energy design?
Yes, I think it's really important to understand what the client is trying to achieve in any retrofit project, and then keeping in mind the site limitations, which are usually a lot for retrofit projects. We should always try and use the fabric first approach to make homes energy efficient, because you can significantly reduce the heating demand for your house by adding in proper insulation, by improving your air tightness, and by reducing thermal bridging. Now, moisture tends to be a major issue in retrofits. So it's very important that you have a moisture, air tightness, and ventilation strategy in place before going on site. Once you have dealt with the fabric, it becomes much easier to deal with mechanical services and renewables and all the other fancy stuff that you can add to your property. I feel that in retrofits, we have struggled over the years with poor installation and therefore poor building performance. So our #1 aim is actually to improve the building performance of the design that is suitable for that building, and not just aim for higher building standards like passive house or Enhabit standards. Now, even if we are trying to create an existing building, we are trying to convert an existing building to a current building standard, it tends to be quite difficult. So what I would say is that we can learn a lot from low energy building standards such as passive house. I mean, low energy designs teach us how to pay attention to detail, how to deal with junctions, edges, and how to deal with the moisture risk, which is exactly what we are missing out in our retrofit projects. I mean, traditionally, retrofits have just gone from the client side to the builder's interpretation. So what I think is that we are missing an important step here, which is design. And I guess this is where consultants and retrofit experts come into place.
Excellent, thanks. And a good call for the design community in all forms, including engineers, to be increasingly engaged, if you like, in the debate. And Lee, I mean, choice is a great thing, but of course, too much choice can be paralyzing and can lead to just overwhelming complexity. So with product specs, why is there no one-size-fits-all solution to make life easy?
Yeah, very, very good question. I think to a degree that question's really been answered partially already. I think when it comes to the design of buildings, there's a lot of variables: new build, retrofit, apartments, housing, schools, offices. Now, the nature of building and building design means there's very rarely a commonality between them. They all vary. It means that the room for products and solutions to go into those buildings that are there to deliver ventilation are too varied. There's intrinsically too many variables in the building design. I suppose there's two primary principles in the way that that's dealt with these days through designers. There's centralised and decentralised systems. People put, in new build particularly, more of a centralised approach very often to more modern ventilation concepts. But in retrofit, it's generally decentralised. It's harder to put complex systems into existing buildings and new ones, of course. You don't design from the ground up. So it's very much application based, which leads companies like ours to produce a range of solutions, all delivering similar airflows, etc., as required for the calculations from the building regs. So I suppose that's one area that's been touched on earlier. The other one, of course, is that some of the tools that are used to calculate energy performance of buildings, such as SAC, although they're a calculation tool, they're used much more widely as a design tool. In effect, people designing buildings use building elements within those calculations and can trade off the performance of different building elements from a carbon perspective, which means that we have a whole host of different customers that approach their buildings in a different way, different fabrics, different specifications, different applications, different external air quality, different acoustic requirements through planning conditions, etc. But those tools become more of a design tool, and they have a certain vision of how they'll deliver the carbon targets that they have to hit through those tools, and they will use ventilation in an appropriate way. And that's optimized around cost, I assume, to deliver the specification required for the constraints that they have. So we end up having quite detailed conversations with how our products fit within the building design, its energy calculations, its air quality requirements, both internal and, of course, to filter external air. In many cases these days, that's becoming very common. Air filtration, air treatment is increasing, particularly in urban areas. So we end up with these solutions that are all based around similar airflows at the end of the day, assuming that you're trying to deliver the minimums. We have some that go on to achieve higher airflows, better quality of air as a differentiator in the buildings. But it means that we don't end up with one common approach. But what I would say is we end up with common categories. And those categories are well dealt with through the building regulations. So you end up with categories and platforms, but certainly not individual solutions where it's applied universally as one solution to every type of building. I don't think that will ever come. There's just too many variances.
Sure. And just one interesting little follow-up there, I guess, of course, as we're talking about these issues mainstreaming and hot topic at present, if you like. In terms of those conversations you're having, could I just ask you, are you having more conversations? And if so, are you having more conversations with the usual suspects you deal with? Or are you having conversations with different parties and new inquiries and other voices coming into the ventilation debate? So just from your perspective.
I think we're having different conversations than we were, certainly 10 years ago. It's progressed. If we go back to the last real material revisions of Part F of the building regulations around ventilation, that was over 10 years ago now. That was when SAP calculations really kicked in from a ventilation perspective. Those conversations have changed. And of course, these days we have other issues as well. We're having conversations with people around COVID at the moment that you wouldn't have had even a year ago. So I think indoor air quality is certainly moving up the agenda, certainly in more recent times. And we obviously have conversations with different level of consultants. It depends on the type of project and the type of build, and the complexity of that supply chain. In certain aspects of the market, things carry on in much the way they always have, but in other areas, slightly different way. And of course, we get slightly different conversations now around air specifically than we would have done a few years ago. As we get airtight buildings, we certainly get overheating risks, etc. And a conversation around air is probably been moved up the agenda in certain applications such as that. So the supply chain may be in relation to consultancy, as we've touched on through other members of the panel there. From the point of view of the complexity of the design, we're probably having more conversations in that kind of space than we perhaps would have done 10 years ago, where ventilation was much more prescriptive. It was a tick box and the solutions were less complex. Excellent,
thank you. Nice insight there. And Alan already mentioned in Dispatch's passive house. Where does it fit into this picture?
Airtightness and ventilation is one of the key things. I think when Wolfgang started looking at the whole passive house calculations and working out his best house, it was all about trying to get value for money, to try and make his house energy efficient and so forth, and basically add lots of insulation. But it wasn't really until you start looking at the air tightness and the ventilation that you get to the final point. and it's really crucial to get the air tightness down to get to passive house. So passive house requirement 0.6 air changes per hour on the air tightness, and it's probably the most difficult part of achieving passive house, if I'm honest, is getting that air tightness to work, particularly on a retrofit. I mean, the retrofit, you can have it slightly reduced. Dushyant was talking about that earlier. It can go down to 1 air change per hour, but it's still really, really difficult to achieve. And that then allows, like Ian was saying, to allow the moisture to be managed and the ventilation to be managed quite well, because you're a nice airtight box. I think I'd like to pull up Ian slightly earlier when he said that when you get down to the passive house levels, you've got kind of like minutes to get the MVHR back on if it runs out. I think minutes isn't really the right way of looking at it. It's probably hours to days. I remember when we did our first passive house and we got down to 0.06 air tightness and we would have an open day. I know I got a bit worried that people were going to sort of stand outside and whether if we all went in at the same time, it would be a problem, and whether people would want to come in and stuff. So I did some quick calculations. And basically, if we had the whole house with the full number of people who were supposed to be in the house, I think it was 10, if I'm quite now. And if they were all exercising, which is when you're giving out CO2, and that's the thing that's going to hurt you, really. It's not any other things. It's an increase of CO2 levels. It would take you, I think it was 12 hours before it started becoming noticeable and dangerous. And I think it was just over a day and a bit before it became a problem, a real danger. Obviously, within that time, no one stopped exercising. No one opened a window.
Yeah.
No one came in or go out. So I think there is a real, it's not that dangerous. And I think to start with, if you're in a house without ventilation, and you're going to be in a worse air quality anyway, so you've got a fair bit of time to sort it out. And of course, with a passive house, you can still open the window. So the MVHR is not working, open the window a little bit, sort it. I mean, that's kind of the natural ventilation. A few windows open and you're fine. So don't get too worried about the air tightness. I think sometimes the air tightness is something that worries people. And I kind of like to call it draft free. It's more about a Gore-Tex coat than a cagoule. So
Okay.
Yeah, so that's part of it. Yeah, I think just looking at passive house compared to, say, SAP, that's something that we did a little bit of research on fairly early on. My camera slipped, hasn't it? It's better. About that and looking at the differences. One of the building regulations doesn't look too much into the insulation of the ducts. In fact, it just talks about it in the loft space, which is, I kind of think that the MVHR should never be in the loft space because you need to change filters and stuff. And so when you're elderly, are you really wanting to go up into the loft space to change a filter? Probably not. And so that might cause problems. So we often look at stuff in terms of the positioning of the MVHR. I remember some projects we had designs done. We had the MVHR in the middle of the house and a duct coming from the front of the house to the unit, the intake and the out extract going out to the back of the house. So this was kind of 4 meters of duct length, bringing in cold air. If they were insulated, they're still losing heat. So there's still, I think on that one, I think it was about 4 or 5 kilowatt hours per square meter losses, which in SAP is not considered at all. So I think positioning of the duct and the passive house methodology is really good in terms of making sure that you get a good quality installation. I mean, Dushyant was saying earlier how it's really important about getting the right design and the correct installation on site. And passive house is really good at trying to do that. It talks about noise as well, acoustics, making sure that the ventilation system is quiet. It has to be quiet in a quiet fridge. And so people often think of mechanical ventilation and stuff like that as air conditioning. They think of that hotel room with the fan whizzing all night and you can't sleep, so you turn it off. Probably the fan on your computer is louder than what you would achieve if it's designed and done correctly. But it is about that design and installation and the commissioning doing it correctly. So it's really, I think the passive house really does put all those in place, which I think is good. And it's the principles then you can use to any level. You don't necessarily need to go to full passive house, particularly on the retrofit. But it gives you the key principles and the building physics and all the rest of it that allows you to make those decisions.
Excellent, thank you. There's some flexibility in there, and obviously with everybody working from home and doing everything else from home 24/7, those occupancy levels in terms of how it performs when everybody's in every room all the time are probably going to be increasingly critical considerations. So having looked perhaps at some of the challenges and the problems, I can see now we've got a good number of questions coming in for the Q&A, which we'll go to in a moment. And anybody who wants to ask further, you'll see a little button there and you can type a question for the panel in anticipation. So just before we go to the Q&A, then I'd like to look at some of the, with rose-tinted spectacles on, if you like, what good looks like and what the positives are. And if we do get things right, as we've discussed, where might we be going? So in terms of air tightness and ventilation. So Lee, why should ventilation be seen as an asset in buildings, not a cost? Why should we see it positively?
It's an interesting point, and I think as people are more conscious of the impact that ventilation can have on their health, the more people appreciate the value of it. In fact, it was good to see yesterday the government video in relation to COVID, particularly, and the importance of ventilation to deal with that specific issue. Generally, it's interesting. Ventilation is not something you can see or feel. Interestingly, when you go in a badly ventilated room, it is. You notice it. And then certainly we have a lot of feedback from customers who move into houses for the first time that have potentially got continuous running, centralised or decentralised mechanical ventilation solutions that are providing purpose-provided ventilation to the whole dwelling all the time. We have a number of feedback, positive feedback from customers in relation to how that has improved their quality of life within their building, particularly those that have potentially had some health issues from poorly ventilated houses as part of that problem previously. We see people really notice it. So ventilation and providing enough adequate ventilation for health is one issue, but the other thing is, and one we must never really forget, and one we concentrate on really, is it doesn't just provide it for health, but it also provides it for comfort. A building that's well ventilated, that's done very well, designed very well, in a very comfortable way, is one that you will notice and one that you will remember. And as we said, and as you said directly there, we're spending more and more time indoors, particularly at home in the current environment. And interestingly, I'm not sure we'll go back to working remotely in the same way in the future. I think we'll all probably work at home more than we did prior to COVID. I'm quite sure that's a trend that we're seeing within our organisation for sure. And I think the fact that we're spending more time in our houses, specifically, ventilation can provide a level of comfort in that environment that's something we shouldn't neglect. And it certainly is an asset. Anything that's providing you better comfort for your house, better health, is something we should consider as important. And historically, maybe it hasn't been.
Excellent. And I think maybe analogy for how you described it at the start, maybe ventilation sometimes seen a bit like the referee in a football game. You only notice it when it goes wrong, when things go wrong. So if the game's going well, then potentially their role doesn't actually get talked about. So yeah, there's a challenge there in terms of perception maybe. Right, I think, Alan, if we're looking at, it's a big question, and I'm looking for a short answer before we move to Q&A, but can every project be eco? And if so, how? I know that's just throwing a word at you, but it's in the title of your organisation. Can every project be eco?
Yes.
Great. There we go. Done. Thank you. If so, how?
Yeah. No, I think they can, but little bit by little bit. So I think there's lots of little bits people can do. So even if it's just reducing your drafts, that will help. If you look at what you buy, making sure you consider what the environmental choices are in terms of material decisions, in terms of embodied carbon and natural materials and stuff. If you just look at every little bit in a little way, but it is one of those things that I think is really important, is do consider the whole package as well. Do consider moisture and ventilation. What you don't want to do is to start adding, I mean, it's lots of insulation and then have lots of problems. So do consider it as a whole. That's probably the biggest thing. So do get that whole house design, do look at it in the bigger picture. And I think there's no reason, we often look at projects over a long period. So you might do little bits at a time. So getting towards the passive house at the end, but doing a little bit in stages. So that's really important.
Excellent, thanks. And Dushyant, again, another big question, but a quick answer. So I'm kind of looking for top tips, absolute priorities. So how can clients get what they ask for with building performance? We have already touched on the idea that, you know, their intentions, design intentions, but it gets lost somewhere between, you know, the drawing board and the installation and how it actually performs. So how do clients get what they ask for? Top tips.
I mean, in terms of air tightness and ventilations, I think the key thing is to get a consultant on board from the initial design stage with your architect, because many architects have never been asked to design a thermal bridge-free design or an airtight design, which is where consultants like us come in. I think for air tightness, it's crucial that your air tightness strategy, for example, what your air tightness layer is going to be in your walls, your roof, your floors, and how the junctions are going to be detailed is really crucial. So you need people who really understand how to do this detailed design so that all the details around your windows and doors are carefully designed, which actually makes a major impact on the overall heating demand of your property. And I think in terms of air tightness, the major reason for its failure on site is the performance gap, which is basically the drawings are not really getting transferred to reality. And I would say that this is mainly due to lack of training of the site team and also lack of knowledge of the design team to a certain extent, where they are not aware of the right air tightness materials or how they should be installed. So at Enhabit, what we usually do is we do something called an air tightness toolbox talk on all our retrofit and new build projects, where we meet with the site team and explain them what exactly air tightness is and why is it so important for this project. What we also do is we take some sample materials with us and we literally show them how they are installed, because the key is literally in getting the installation right. So it's really important that the person who is doing the installation really understands what he's doing and what he's trying to achieve. And lastly, what I think is that on all retrofit and new build projects, when you are really focusing on air tightness, you should have somebody called an air tightness champion, who could be your site manager, who could be anyone from the site team, or it could be the client himself or herself, who can just take up the responsibility and make sure the installation is done properly on site. So technically, I would say that the key is to get the right consultant or retrofit experts on board from an early stage, and also make sure that your contractor is experienced and is capable of achieving the energy target that your property is aiming for. And I think it's a similar case with services as well, especially like MVHR and heat pumps, which is not that well known. It is really important that you have an expert design team on board who's going to integrate the mechanical design and the fabric design together and look at your entire project as a whole house approach, which would be really useful to meet your energy demands and get your house to a low energy standard.
Excellent, thanks. So not only getting the expertise on board early, but also, in truth, a little bit of policing in terms of the delivery end and what happens on site is also essential. And then, Ian, lastly from me, before we go to the questions, and they are queuing up now nicely. We talk a lot about the buildings as if they were just things that nobody ever interacted with. How can buildings be made to work better for the people in them?
Well, I think the key word is engagement, and that's with all stakeholders. That starts at the construction stage, well, it starts at the design stage, construction stage, the handover stage, and the occupant engagement. And at the design and construction stage, I mean, one of the things that are starting to happen now, we've got progressive changes to building regulations. We've got the Future Home Standard, which has seen revisions to Part L and Part F. We've had the new homes has been out for consultation. The consultation closed earlier this year. The consultation responses are due out. Existing dwellings and non-domestic buildings is going to be out for consultation shortly. And if anyone's looked at the new dwellings standard, they'll see that there's been quite a few changes to the ventilation. There's issues to do with the performance gap, where we're looking to reduce what been talked about previously as being a key issue, both in terms of thermal performance, but also ventilation is part of that. Air tightness, we're going to see 100% testing rather than sample testing. Ventilation rates are not necessarily changing per se in the standard, but the levels of demonstrating compliance are changing. I mean, future changes to standard, you could argue, well, okay, the current ADF for ventilation really covers wintertime ventilation rates, and industry as a large are following that and saying, well, we'll just put in ventilation just for winter, and then in summer you can open the windows. To me, that's not good enough. I think we should provide a year-round standard that is suitable for ventilation at all times of the year. But again, all of this leads to then what do the people who live in the buildings, work in the buildings, how do they interact with it? How do they get the best out of it? And that's going to be started to move by consumer demand. I think this pandemic might have quite a lot to do with it. The amount of ventilation diagrams on the news over recent months has really engaged people. You just need to go onto Amazon and start Googling indoor air quality monitors, and there's hundreds of the things now for sale. And there's lots of reviews about them, both good and bad, but it means people are engaged, people are buying them, people want to know about the air quality. We might move to a point when actually people don't buy products from the likes of Vent-Axia. What they do is Vent-Axia put them into buildings and people buy the air quality from Vent-Axia. That might be a solution, who knows, because in that way, Vent-Axia and their competition will make sure there's good air quality. They're managing the ventilation system, and it could be a potential solution. So the market's waking up. I think the industry needs to do the same.
Excellent, good point to close. Yeah, and the consumer market is definitely coming alive to some of the issues. And as you suggest, it's like that old analogy of people buy light as a service rather than a bulb as a product. You know, maybe that's where we're going. They're buying air quality rather than the actual kit per se. So maybe that's where the discussion is going to take us. Speaking of which, then, we are opening matters up to our virtual floor. We've got a good number of questions. So what I'm probably going to do, if you guys can see them on the screen, is fire them out there, and I'm relying on you to wave a hand or jump in so that we can get a few of them as quickly as possible. I said on social media, I said, you pose them, I'll ask them. Alan, Ian, Dushyant and Lee will answer them. So here we go. So first one coming up, this is actually, many are from named individuals. This is from an anonymous attendee. How does ventilation and air tightness fit into the future homes standard picture? Would anybody like to volunteer a response on where it fits with future homes?
I can maybe help with that. On the future homes consultation, interestingly, part L and part F are being revised together. Interestingly, ventilation rates are actually increasing within the proposed documentation. So with the increase in air tightness and insulation levels and the reduction in carbon emissions of the building, the ventilation rate is proposed to be changed. Part F is being modified. There is actually an increase in both passive requirements from the point of view of some background ventilation rates potentially increasing, and also there's a proposal to increase the mechanical ventilation rates that are required, particularly around continuous systems. There's an uplift in the ventilation rate that will be required just to meet that requirement going forward. So the important point to note under the future home standard is both energy efficiency and ventilation regulations are being improved in parallel, with the ventilation rates being increased in line with that increase in energy efficiency as well. So it does directly get covered in the future home standard. It does refer to part F, and there is a proposed revision to that, which mechanically improves the ventilation rate, and it's quite material. In some buildings, it would be a material uplift of over 40% in relation to the background and the continuous ventilation rates in some applications.
Excellent, and I think actually we have a couple of questions from Nathan Wood as well, which very much relate to that and follow on, which I might get in before maybe the panel, others in the panel join in. One is ventilation rates in part F are minimum rates. Why do MVHR manufacturers kind of spec systems to these minimums rather than rates for the best airflow possible? And they've also asked, does the panel have a view on training and competence for installation of MVHR? So two kind of questions around that then. First one, why minimum rates? Why not for the best possible? Secondly, views on training and competence. Alan, you're putting your hand up for some of that.
Yeah. I think there's a bit of a problem I have with increasing the ventilation rates, because as you increase the ventilation rates, each time you ventilate the building, you're losing more heat. So the ventilation unit, even the best in the world, is probably around like 92%. So you're still losing some heat each time you. So if you turn up the ventilation unit and increase the ventilation rates, so therefore you're losing more energy. I have a little bit of a problem in that all rate for all buildings. So what they've done is they've kind of allowed for kind of bad workmanship on site. So you've kind of looked at it in terms of what might happen in bad situations, what's probably happening now in terms of people turning stuff off. So you kind of want to over ventilate just to make up for those differences. And it's been shown in a lot of research on how buildings actually perform against how they were designed. There's a huge difference. I mean, a lot of things that can be over 100% worse performing than they were designed to perform. And I personally feel that air tightness and ventilation is part of that problem. So I think we need to get the right amount of ventilation, but don't get carried away with more ventilation is better ventilation. It needs to be the right amount. So there should be an upper limit as well as a lower limit. So that's something I'd have a question on.
Great. And Ian, I think I saw your hand going up, unless you're just waffling.
Just a couple of things really, just to come back. Ventilation rates. What's changed in Part F is, as Lee has suggested, is there is a change in the ventilation rates that are required based upon the number of rooms in a building. What hasn't changed is the background ventilation rate per se. That's still left unchanged. What the new Part F has done has taken out a lot of the assumptions that the current Part F has, particularly in respect of occupancy in homes. The intention of that is to make the standard, the guidance around the standard, simpler for readers to follow, makes compliance more likely if it's easier to follow. So taking out some of the assumptions that we expected the designers to consider, such as how many people will be occupying this home, those assumptions have been removed. And as part of removing those assumptions, what's happened is the ventilation rates seemingly have gone up. It is nonetheless, as Lee said, it is going to be material consideration for ventilation designers. I think one of the other issues around that, and that comes to, it's about headroom really, and this is where some of the issues are with building regulations or the building standards specifications for minimum ventilation rates. And that is, it's about setting the minimum amount of ventilation that's required. What we're trying to overcome this time is to try and get some capacity in. So when the building has got, in a domestic context certainly, a greater level of occupancy, even if it's for short-term periods, everyone goes around at Christmas, maybe not this year, but who knows, we'll find out soon, that the ventilation can cope with a bit more capacity, that actually the minimum isn't what goes in to operate at maximum at all times, that we want to build in some capacity into these systems.
Can I add there as well? I think with many modern ventilation systems, there's a level of controls included as well. So a lot of the ventilation systems that we provide, there's a minimum kind of background rate, the trickle rate that the ventilation provision is, the continuous rate, but they're often automated with sensors these days, even simple sensors like humidity sensors that switch them to boost if humidity levels increase. So the provision is potentially higher than the base rate anyway, and it's automated and the system runs at a higher level if it's needed. I'd also just like to make one more point in relation to install performance. I think it is important to deal with that. We've said that we create some headroom, etc., on the basis of ensuring that partly because they need to be installed correctly and work well. And there's been research really does indicate that they don't necessarily, the more complex systems specifically. We do have a mechanism in SAP at the moment that if you're a competent person, the conservative ratings, if you like, or the downgrade of that ventilation performance can be reduced if a competent person does it over anybody else. We actually lobbied as an industry to include a mechanism like that encouraged contractors to become better informed, if you like, and better qualified to install a more complex systems, and that there is that competency person scheme that's actually run, NIC, EIC run one, where you can become, in effect, qualified and go on a training course, and it gives manufacturers and people who run that course the opportunity to tell installers what good and bad practice is. And they can sign up to that scheme. It reduces the conservative ratings in SAP, so it helps the house builder or the developer reduce the carbon emissions of their building, and at the same time ensures that we do a better job of installing ventilation, because it is important moving forward. And it's far from perfect now, but we do believe we're on a path to improve that.
Excellent, thank you. And if I could just bring maybe Dushyant in briefly there, you have already touched on the need for training and competence. Obviously, we mentioned your toolkit, but also there's another question here from Richard Hooper, is saying the emphasis on keeping buildings airtight and insulated, we're seeing greater future cost in terms of cooling homes and buildings. How is this factored into the methodology? So also there's a trade-off in terms of cost going up for cooling, the more airtight you keep things. Dushyant.
I think this is where the whole house approach comes in, where you're designing on all different elements, including overheating in summer. So what usually happens with all the new MVHR units that are available in the market, that there is a summer bypass mode, in which case what happens is that in summer your heat is not getting recovered and it is just getting thrown out of the building, so that the external air, which is say at a temperature of 20 degrees, that is the same air that's entering your living spaces. So you are not really making your house even more hotter than what it is. And I think the other main key issue is that with overheating, windows and shading is really critical. So it's really important that when you're designing your retrofit or new build property, that you are looking at what sort of glazing you are using, on which direction you are locating all your windows, what sort of shading strategy you have in place. And I think if you look into all these factors, it wouldn't cause overheating in your properties.
Excellent, thank you. And I'm seeing if the panel are okay, just for a couple of minutes, got one or two quick final questions to take, because they have been coming in thick and fast. This might be one for you actually, Alan, because you touched on the noise factor earlier. Should the new part, this is from Nick Conlon, should the new Part F include mandatory testing of noise levels from ventilation systems, given that people simply switch them off when they're too noisy?
Yes.
There you go. Excellent. I don't know, Lee, do you have a comment on the noise factor?
No, I mean, obviously, noise is critical, and I think we've given various examples of where that's actually controlled as well in certain standards, passive house being a good example. I mean, obviously, we would have our name written on the products that go into people's houses. So if there is a noise issue, we're the first ones to get the call. So it's in our interest to make sure that our products are trouble-free. And I realise from a position of bias, I've lived in properties both with continuous running ventilation systems and without, and actually modern ones are designed with very, very tight acoustic requirements. We can provide products that are acoustically enclosed as well. So where we have very small properties with a service cupboard that is very close to habitable rooms. To put some perspective on it, for the athletes village in the Olympics, we had a heat recovery unit running that was actually going to be in the kitchen after the games, but it was a bedroom during the games. And so we actually had a heat recovery unit running in an apartment in a bedroom that an athlete slept in. And actually, we never had any issues with noise. We managed to acoustically attenuate those accordingly. So I'm comfortable that the ventilation systems themselves can be designed to be quiet. And if we get installation and competency correct, I'm quite sure we can deliver quiet installations. And hopefully won't need to get to a stage where we're measuring the acoustics of every installation. But I understand the concern and the risk. But I believe if we get the other things aligned correctly, we shouldn't need to. These are very quiet, very, very quiet fans running. They're centrifugal. They're designed specifically to run quietly.
Excellent, thank you. And we have one very specific question from Mike Croker. This is an air tightness question more than ventilation. How does the industry stop post-test removal of skirting board sealing? So I guess you could say post-test for air tightness, how do you stop things going backwards and things changing, which effectively nullify what's promised in the test? Ian, sorry, did you say, what did you say, sorry?
Yeah, two things. The new Part L provides what's called building quality guidance. That's going to be reasonable provision. Reasonable provision means that building control can use this as a specification list, if you like, to look at and when they come to sign off a building. Build quality guidance includes provisions for air tightness, thermal bridging, and all of the design and construction measures that should be considered during the design and construction process. So if you are gaming by using inappropriate methods, whatever it is, that will no longer, once this comes into force, likely next year, will no longer be permissible. The second thing I wanted to say was just coming back to the ventilation noise issue. Noise was considered in the revision to Part F that's coming out. However, there's some internal discussions about how that should be addressed. And Part E, which deals with noise, may well be the place where noise associated with ventilation systems and other building services such as heat pumps needs to be addressed. It's not for Part F. The other thing about noise, there's an MVHR in the cupboard right behind me. I don't think you can hear any whirring in here. It can be done.
Excellent, thank you. On that note, with a real life case study example there, thank you very much. We're bang on time, done the hour. There are one or two questions we didn't get round to, but thank you very much for everybody submitting them. So in closing, big thank you to all our panelists, Alan, Ian, Dushyant and Lee, to the lovely people at Vent-Axia, our sponsors today, to yourselves out there in Zoom land, our virtual audience for your questions. A reminder to check out Elemental, www.elementalexpo.com, online community for professionals focused on innovation in heat, water, air and energy within the built environment. Find the full diary of events on the website, as I said at the top of the show, including the next two webinars in the series, many more besides, available as a back catalogue on demand. That's it for today. Thank you very much to the four of you. I've been Jim McClelland, editor at SysMean. Thanks for watching. See you all again soon. Thank you. Bye-bye.
Thank you.